So I've given you some links here which you can practice just putting in some random functions and seeing how the square root outside function can affect the domain of the inside function. Okay, so here we have our inside function is going to be this upside down parabola 60 minus x squared. So this is our inside function. Okay, and then the output of this is going to be applied to the outside function square root. Okay, and when we do that, notice what happens. We're gonna end up losing parts of this function. Okay, but because basically the y values here end up being the input for this function, and the y values that can be used are only going to be these positive y values. Okay, so remember that the negative parts disappear. You get rid of those negative parts, and so the output here becomes the input for here. Okay, and that's why we get rid of this negative parts here. So what ends up happening is for this composite function, although this is all real numbers, this restricts at all real numbers, and now we can only use the domain from negative 4 all the way to positive 4. And everything else has to go away because all the other parts give us negative outputs which cannot be used into there. So then what ends up happening is our domain for the function becomes restricted from negative 4 to positive 4. Okay, although the inside function has all real numbers, because of the restriction on the outside, we have a restriction on the domain. And then the range of this function doesn't really change because the range does change because we can only use the input values from 0 to 16. So our output function can only give us values from 0 to 4. Okay, and we can see that very clearly when we see this graph here. So if it's hard to kind of visualize, play around with the functions, see what different inputs are gonna work inside the square root. Okay, and this general idea of an inside and outside function, you can actually change the outside function if you want. There's other things that have possible restrictions, and we can see how that works. But for now, we're just going to focus on how the outside function is a square root and how that restricts values of the output of the inside, so that when we square root, we can't square root all of it, so we end up with a restricted graph here. Okay, so these apps here help us visualize these and help us predict things or look at things when we can't see them very easily. And as we see them, we can start getting a better sense of them. Okay, and that's very important to start getting a better sense of what happens to graphs as they get transformed. So this one here, I've given you a relatively simple example. I want to try this one without a graph. Okay, so we have this 1 minus 3x as the inside function, and the outside function is our square root. Okay, so I'm going to just highlight that. So outside function is the square root function. That's our g function, and embedded inside that g is our f function. So the domain of f of x and the range of f of x, the inside function is all real, right? It's a linear function, so our domain and range has no restrictions. However, once we put it inside the square root, now, or because we have a range that is some of it's negative, we can't use the negative parts in the domain here. So that restricts our domain. Okay, so the domain of the outside function then becomes restricted. The domain is, we can't put negatives in, so we need to figure out at what x's do we start getting negatives. And that's going to be based on where the output is equal to 0. And we have to make sure we understand which side of that output we want. Okay, so we have, in this case, if I solve for this, I'm going to end up with x equals 1/3. And this is where it's useful to know the direction of things going on. We can always test it, but we know that this is a negative slope. Okay, so anything bigger than 1/3 is going to give us negative values. Okay, and we can't use that negative output. So our boundary is 1/3. That's going to be 1/3 there. And we want this side. Okay, so then this becomes the domain of our new function, of the embedded function. We want x's that are less than or equal to the 1/3 value, which is our boundary. And then our range is going to be restricted because it's going to be bent down. Okay, we're going to take all the positives and bend it down. Well, that means that we just need to worry about the y values, and they're going to be above 0. Okay, so that's our original graph. It's going to get bent down as a transformation. Although it gets bent down, it's still going to go up to infinity. Okay, so y is greater than 0. So if you have a hard time visualizing this, use those apps, practice some animations, okay, see what happens when you put different things in there and how the output domain, the composite function domain gets changed depending on what the input function is, okay, or the inside function. And try to see that where the inside function is negative, that's what restricts the whole function or the composite function.